For question number 5, we need the product rule to be able to differentiate this x times e to the x. It's not easily differentiable unless we have the product rule. So if we have the product rule, we could do this problem. And this problem involves a spaceship traveling in the path of the parabola, x squared minus 9 in blue, and then also in the path of this exponential function, e to the x e to the x, which I've shown in red. So that red, it represents a path. And it says that the spaceship A in blue, it lets go at x equals 2. So at that point, it's going to let go and it's going to fly in this direction along that green line. And then spaceship B is going to let go at x equals 0 and it's going to fly along that line there. And the intersection point is going to occur right at that point there. Okay, so to do the problem, we need to first of all find the derivatives of each of these functions so that we can calculate the slope values. So I'm going to start off with the spaceship A. So y prime of spaceship A, when I differentiate this, I'm going to end up with 2x, and the y prime for spaceship B, and this is where we need a rule to be able to differentiate this. Using the product rule, okay, if you don't know the product rule, we'll cover this a little bit later. So it's going to be 1 times e to the x plus x times the derivative of e to the x is e to the x. And then using these two functions, then we can calculate the y prime of A when it lets go at x equals 2. So the slope is 4. And for spaceship B, we're going to find the y prime at 0. And that's going to end up being e to the 0 plus 0, or just 1. So once we have that, we need the y coordinates to be able to write the equation in a line. So the y coordinate at x equals 2, when I plug it into the equation, is -5. So the coordinate is at 2 and -5. Then to write the equation of the tangent line, then we have the slope. It's going to be 4, and then in point slope form, it's going to be x minus 2 minus 5. That's the equation of the tangent line. So that's that green line I've shown there. So maybe I'll just highlight that. That green line is going to be the tangent line for that. And then for the other function, I've got the slope. Okay, I need to find the y coordinate at 0. When I plug in 0 to the original coordinate, into the original function, I get 0. So I've got the coordinate is going to be at 0, 0, which we can see right at the origin. Now I can write the equation of the tangent line because I have the slope, which is 1, and the coordinate. Okay, so this just simplifies to y equals x. Now to find the intersection point, that point right there, hold on here, that point right here. To find that intersection point, we make these two equations equal to each other. So I get 4x minus 2 minus 5 is equal to x. That'll solve for the x value. So I end up with 4x minus 8 minus 5 equals x. 3x equals 13. And so the x coordinate is going to be 13 over 3. And then plugging it back into the equation, well, that's y equals x, so y equals 13 over 3 as well. Okay, so that would represent the coordinate of the intersection of those two tangent lines.